So let's review some of the things we learned about exponentials and logarithms. First of all, and probably the most important thing, understand that exponentials can be written as logarithms and logarithms can be written as exponentials. And if this base isn't there, if that base 10 is missing, it's what we call a common logarithm or a base 10 logarithm. Now if we have a base e to the x, we can write that as a logarithm. We use ln, which is short for a natural logarithm or a base e. If you can convert back and forth between these, it helps you a lot when we get into actually doing some problems. The three properties we talked about were the product property, where multiplication can be broken into two logarithms with addition, or two logarithms with addition can be put together with one logarithm and multiplication. A quotient property where division can become subtraction, where subtraction becomes division. And the power property where the power in a logarithm can be brought down in front, or if something's down in front, it can be taken up and put as a power. The other property or formula we learned is to change the base. So if we have a log with some base that we can't do, we can change it to something we can do, like a common log or a natural log. And we take the log of m over the log of b, log of m, natural log of m over natural log of b. So let's do some examples. This first example here is asking for the log of 7 with a base of 4. I cannot do a log of 7 base 4, so I'm going to change this to something I can do, which is a common log of 7 over the common log of 4. And that will give me some decimal. I can use my calculator to actually calculate this. This one is using a base 5, but notice that there's division in here. So we're going to break it into two logarithms. A logarithm base 5 of 25, a logarithm of x base 5 with a minus sign. So we're using the quotient property. Now, since this is all numbers, I can actually do this one. I can change this to a common log, do the common log of 25 over the common log of 5. That's going to turn out to be 2, and I get 2 minus log of x base 5. If I have numbers, I should do them. If I have things with variables, obviously I'm not going to be able to do those. For this one, since they are the same base and they're trying to subtract, I'm going to have a quotient as well. But I also notice that there's this 2 in front. So I'm going to take that 2 and put it up here as a power. So I'm going to have 7 squared. And I'm going to have an x on top. And now I can write them as a single logarithm with a base 3. And again, if it's numbers, we should probably do them. So instead of writing this as 7 squared, let's write this as a log base 3 of x over 49. For this one right here, same idea. We have a 2 in front. Even though we're only dealing with a natural log now instead of a log base 3, the properties still apply. So we're going to put this 2 as a power. We're going to turn this minus sign into division. So I'm going to have 15 squared over 75 with just a single log out in front. 15 squared is something I can do. I should do that. So this would be 225. And 225 divided by 75. And now I would probably run this through my calculator and get an approximate answer. Down here we're in a similar situation. We have a natural log and a whole bunch of things that are put together. We're going to break them into pieces. I've got multiplication, I've got division, and I've got powers. So I'm going to have 3 different logarithms, and this time they are natural logs. So I'm going to have the natural log of x to the 20th plus the natural log of y to the 5th minus the natural log of z squared, but the powers, using the power rule, tell me the 2 comes down, the 5 comes down, and the 20 comes down, and they go in front. And I expanded this into smaller chunks. Whereas up here, I was taking smaller chunks and putting them together as a single logarithm. Continuing with the solving, now I have a similar situation where I have two common logs that are being added together. I'm going to put those together, but first I'm going to put this 2 up as a power. So I'm going to have x squared times 4. And now they want me to solve. If I don't know what to do with this logarithm, I'm going to try writing it in exponential form. I know this has a base of 10, has a power of 2, so this is 10 squared equals 4x squared. Now I can solve this. I can divide by 4 on both sides, and then I can square root both sides. So I divide by 4, and I get x squared equals 25. And when I square root that, I get positive 5 for an answer. Sometimes they're already put together, but if you don't know what to do, if you're not sure how to solve, rewrite this. This is another common log. 10 squared equals 3x plus 1. Just by rewriting it as an exponential instead of a logarithm, it now becomes a problem I can do. I subtract 1 from both sides, I get 99 equals 3x, and when I divide by 3, x is 33. Now in number 8, I have an exponential, but notice that my variable is in the power. I need to be able to bring that down, but I can only bring that down if there's a logarithm. So I'm going to put a logarithm into this problem. That will allow me to bring this 7x down in front of the logarithm, and now I can start my solving. They're multiplying by a log of 4, so I'm going to divide by a log of 4. So 7x equals whatever this decimal is. No, the logs don't cancel. No, I can't divide 250 by 4. I have to do the log of 250 divided by the log of 4. And my last step is to divide by 7. So whatever this decimal is, divided by 7 is my answer for x. This one's very similar. I have a variable in the exponent that I want down. I can only do that if there's a logarithm. So if I log both sides, now I can bring this 4 minus x down in front. And now I can start doing my solving. So I can divide by the log of 12. So I have 4 minus x equals whatever this decimal is. Subtract my 4 from both sides. I'm just doing my balance scale. And divide by -1. Whatever this decimal is, subtract 4, and when you're done, divide it by -1. That'll give me my decimal answer. This one's very similar to the problem we just did, but notice now we have this e. Anytime you have e, whether it's a base, whether it's in your problem, you're probably not going to put in a common log. You're going to put in a natural log. And again, this x minus 2 comes down in front, and I put a common or a natural log on the other side as well. Now, the great thing about natural log of e is they cancel each other out. Now my solving is really simple. I add 2 to both sides, and x is equal to whatever the natural log of 12 is, plus 2 more. This one also has an e in it, so we're going to do the same thing. The only difference here, I need to move the 5 out of there first. Then I need to get the 2 out of there. Now I can take a natural log of both sides. I can natural log each side, which brings 3x down, and the natural log of e is going to cancel each other out. So solving is just a one-step problem. Divide by 3, and x is equal to whatever that decimal is. Couple of extra formulas that we saw throughout this unit on exponentials and logarithms. We talked about a basic exponential. We talked about what h, k, and a do. Same thing with logarithms. We talked about h, k, and a. We had a compound interest formula, an exponential growth, exponential decay based off of rate and time. And then we had a compound continuously formula, which was using a base e. P stood for the principal, and again, rate